Hello, Raji ma'am, are you there?
Yes, I'm ready.
Okay, ma'am. Shall we start?
Start.
Okay. Kavita ma'am, are you ready, ma'am?
Yes, ma'am.
Okay. So shall we start, ma'am?
Yes, ma'am. Sure.
Okay, comparing team, kindly start.
Okay, ma'am. Good morning to all the dignitaries, hosts, and participants who have joined us online today. It's my privilege to welcome you all this exciting workshop on recurrent neural networks and LSTM using KERAS. We have a day filled with insightful knowledge sharing, and I hope each of you will make the most of it. Without further ado, let's begin this workshop with the invocation of our state song. I request all of you kindly stand up for the Tamtai Valtu.
Thank you everyone. To start today's session, I would like to invite Dr. A. Vijayalakshmi ma'am, Assistant Professor and HOD in charge in the Department of Computer Application, to give the welcome address.
Dear, shall I start? Good morning, everyone. It gives me immense pleasure in welcoming all of you to this online workshop on RNN using KERAS. My sincere thanks to our beloved Principal Madam for the constant support rendered. A warm welcome to our resourceful guest speaker for her august presence in virtual mode. Once again, my hearty welcome to all participants connected in this online event. Thank you.
Thank you, ma'am, for the warm and gracious welcome.
Now, the moment we have been waiting for, it is time to hear from our chief guest, Dr. R. Kavita, who has the vast expertise in the field of computational science, is sure to enlighten us now. Now, it's my pleasure to invite Mrs. C. R.T. Bharani, ma'am, from the Department of Computer Applications, to introduce our esteemed chief guest, Dr. R. Kavita, Associate Professor in Department of Statistics and Data Science at Christ University, Bangalore.
Cheerful morning to all. Think out of a box and create a learning experience where the learner can interact with the content and their brain. I'm Aarti. It's my absolute pleasure to extend a hearty welcome to each one of you present here at National Level Virtual Workshop. We are thrilled to witness such enthusiastic participants and highly learned scholars gathered online to deepen their understanding of RNN and LSTM using KERAS, this significant topic. We are fortunate to have with us today our chief guest, Dr. R. Kavita, Associate Professor, Department of Statistics and Data Science, Christ University, Bangalore. Now I would like to throw some lights on her achievements. She has 21 years of extensive experience in teaching and 13 years of research experience. She has been authored a book titled Machine Learning with Python. She has 35 conference presentations and 20 publications. She presented her research work in conference held in Singapore, Malaysia, and Thailand. We are honored to have our chief guest, Dr. R. Kavita, here today to share their knowledge and experience with our students and faculty. It's my privilege to welcome all the faculty members and students to set out on this intellectual journey. Without any further delay, let's begin our journey into the interviewing world of workshop. I welcome you, ma'am.
Thank you, ma'am, for the introduction. Shall I start the session?
Thank you, ma'am, for that wonderful introduction.
Now, the moment we have been waiting for, it's time to hear from our chief guest, Dr. R. Kavita, who has vast expertise in the field of computational science, is sure to enlighten us now. I request our chief guest to kindly take over the share her valuable insights.
Thank you. I'll proceed with the session. Before that, at the very outset, I would like to apologize all for the postponement of this workshop because I was down with a cough and fever, so I couldn't do it on time. Sorry for that. Now we shall proceed with the session. Give me a second. I'll share the screen. Is the screen gets shared? Can I get confirmation? Is the screen is getting shared?
Yes, ma'am.
Okay. Thank you. Thank you, Vijaya ma'am, for giving this opportunity to present in a national level virtual workshop. So this session is about recurrent neural network and LSTM using KERAS and TensorFlow. And first let us introduce ourselves into these two concepts and why it is needed, how it is working, and then we can move ahead with the demo part using Python framework. Okay, so the agenda of this session would be like this. As this RNN, LSTM, and all other learning models are coming from machine learning, which is a subset of artificial intelligence, I would like to spend 2-3 minutes about natural intelligence. Then we can move ahead with the RNN. So what is RNN and what is the need for RNN? What is the architecture and how that RNN works? Then we can move towards LSTM. So both are related to sequential series of input. Then already RNN is there. Why we have to go towards LSTM and how LSTM works? And then we can see some use cases, sample use cases where this RNN and LSTM works. And what particularly if you take one domain like NLP, what challenges we will face when you deploy these kind of learning models, then we can move ahead with the demo part. So as a human being, we think that we are only having intelligence, but that is not the case. If all the creatures, living beings created by God will have some sort of intelligence. I would like to quote 3 scenarios here. So first one, Dr. Monkey. So this is the incident that happened actually in Kanpur railway station. So we might be knowing that in a railway station, electric lines will be passing on. Some monkeys were playing on those electric lines, and one monkey got electrocuted and shocked and became unconscious, and it fell down. And in between the railway track, some stagnant water will be there, right? So other fellow monkeys, what they were trying to do is they were beating the unconscious monkey and they are trying to dip that monkey into the stagnant water between the railway tracks, and they are trying to rescue that unconscious monkey to make it like conscious. So as a human, we know that if a person become unconscious, we used to splash water on their face and we used to tap on their cheeks to make them conscious. But who thought that this monkey to do all these things? So even animals are having intelligence in it. And if you see, the other form of natural intelligence, it is lotus leaf effect. So you can search in the Google for lotus leaf effect application. So many applications are there. We all know that when you pour water on the lotus leaf, it will not be there stagnant there. It will roll down and it will form like a bead and it will roll down. Actually, the lotus leaves are having some self-cleaning properties. So you can see in the right side of the diagram that the lotus leaf is not like a shiny surface like all other leaves. It is like a bumpy surface. So what is happening means if you pour water on the lotus leaf, it is rolling like a bead and it is coming down. When it is coming down, it is taking all the contamination particles, the dust particles, so that it is clearing itself, so that it is doing self-clearing. Okay, and then it is coming down. So that intelligence is taken and it is deployed into our mobile covers and the car windshield wipers, and so many effects are there for this. So even the lotus leaves are having some sort of intelligence. And the last scenario to quote, problem solving skill in crow. So this story we would have heard from our school days itself. And if you keep so many jars filled with water, first crow will go in search of the jar which is having maximum amount of water. Then one more thing crow knows, like it has to throw some particles into the water jar so that water will come up, right? So if you keep some particles, crow know which particle to take to throw into the jar to make the water come up. If you keep some thermocol balls and if you keep some pebbles, marbles or stones, then crow will choose the stone, not the thermocol. Because crow knows that if you put that thermocol, it is a lightweighted product. So if you if you throw it onto the jar, it will float. It won't get the water. But if a stone is thrown into the jar, it is a heavyweight product. So it will sink. All the stones will get sink down and the water level will rise up. So even the crows are having some sort of intelligence. So as an IT professional, what we are trying to do is we are taking the intelligence that is existing in the nature. It may be with animal or plant or birds or even human beings, whatever it is. We are trying to mimic it in the form of artificial intelligence, and we are having so many learning systems. Like machine learning is there. In machine learning, we have supervised learning, unsupervised learning, reinforcement learning, and then advancement of machine learning is deep learning. So, and in deep learning only, we are going to deal about this RNN, LSTM and all. Okay. So already machine learning is there to deal with all sorts of problems. Why we have to move towards deep learning means, in the traditional machine learning, you are giving the input and there is a separate feature extraction methods. So many techniques are available. So you have to employ appropriate feature extraction methods and extract the features, and those features are need to be given to a classification model, that is ML model, and you will get the output. So where the human part is needed means you have to give the input as well as you have to do the feature extraction. But when it comes to deep learning, you need not bother about which feature extraction technique you have to deploy, how to extract the features, all those things, because the final output depends upon how well you are giving the features. If you give good features, you will get a good output. So the performance is having direct correlation with the feature what you are giving. So now in deep learning, our job is only to give the input. The deep learning technique itself automatically doing the feature extraction and the learning model, everything, and will be done by itself and it will give the output. So we need not bother about which feature to extract, how to extract, which are all the features. Like after extracting the features, we have to reduce the features, feature selection, feature transformation. So many things are there that we need not bother about here. That's why we are moving from machine learning to deep learning. This is one of the reasons. Okay. Now, deep neural networks, just one or two slides related to this. So it's a type of machine learning algorithm which is using multiple layers of neural networks to solve.
First internal ஒண்ணுமே எழுதல நீ. செகண்ட் இன்டர்னல் எழுதல. என்ன பாஸ் பண்ற மாதிரியா இல்ல அரியர் வைக்கிற மாதிரியா? எப்ப படிப்ப? எப்ப படிப்ப இவ்வளத்தையும்?
Can someone mute?
The participants are kindly requested to mute yourself.
Okay. So in machine learning, you would have learned about artificial neural network, which will be having some sort of layers called input layer will be there, and you might be having hidden layers, and you might be having output layers. Okay, and the strength of the deep neural network lies in hidden layers. So we are going to use multiple layers of this hidden layer in neural network to solve the complex mathematical functions, so that you will get a fine-grained features. So because in deep learning, we said, right, automatically the features are getting extracted. So many hidden layers are employed with many hidden neurons so that you will get fine-grained features. And these deep neural networks are more complex than the conventional, traditional artificial neural network because they have multiple hidden layers. Initially, when deep learning started with the journey, it was not so much popular because of these two reasons. One is it requires large amount of labeled data. Getting the labeled data is very costly. Getting unlabeled data is very cheap in the real world. Why? Because to uh, give the label for your training data, some domain expert is needed. Suppose if I am working on CT scan images or MRI scan image, so to label that particular data, I need a radiologist, I need a doctor. If I am working on some sort of smart farming or precision agriculture, I need an agriculture officer or agriculturist for that or farmer for that. So getting the labeled data is very costly in real world. And another one is deep learning requires substantial computing power. So some of the projects which we will be working will not be possible only with the CPU. We need GPU, and sometimes when we used to work and all, one particular run will keep on running for 3-4 days. So we used to keep the system on in the laboratory for those many days. Okay. So these two are the reasons why it was not popular. But now, because of advancement in storage capacity and other chips and all, now this is becoming popular, gaining popular. And you see, just to initiate with the task, randomly some points are given, and now the model is trying to learn from those points how to dance. After 10 minutes, this is the status. After 10 minutes, this is the status, left hand side. So model does not know how to dance, which point to be connected, where. So the sequence, nothing is properly done. But after 48 hours of learning, after 2 days, the computer masters the art of dancing. Okay, that's the complexity of deep neural networks, because nothing will come to us simply just like that, right? So it is coming with the challenge of complexity also. And these are all the common deep neural networks like CNN, recurrent neural networks, recursive neural networks, LSTM, GAN, and autoencoders. Nowadays, these GANs are getting popularized, you might be knowing. So as per this session's agenda, we are going to look into recurrent neural network and this LSTM. So we'll start with RNN. Why we have to go for RNN? So already I am having some neural network model. Why I have to go towards RNN? So a vanilla neural network means plain neural network. Consider that a ANN. Takes in a fixed size vector as input. So the ANN first record, if you are giving with 3 features, then second record also will be with 3 features. Third record also will be with 3 features. Okay. So like that, the plain traditional neural network takes in a fixed size vector. So here you can make out, this is first input, second input, 3 inputs. So 3 inputs are given means all the training data will be having these 3 inputs, this sort of 3 inputs only. So it cannot be used in situations where there is a series type of input with no predetermined size. Consider that I'm giving one word. So word, sometimes it may have like a 3-letter word. Sometimes it may be like 5-letter word. Sometimes it may be with more than that also. Okay, some series of type input which is not having predetermined size. These are all words. Take sentence. One sentence will have, sometimes one sentence will end up with only 3 words. Sometimes a sentence may have 7 words. Sometimes sentence, you can build a sentence with 10 words also. Take a paragraph. Paragraph can have 4 sentences, 5 sentences like that, it keeps on going, right? So there is no predetermined size. So that cannot be easily given to the artificial neural network. Okay, fine. Now, so I know that artificial neural network, if I give one input, it is giving one output. So what I want now, so here I am having the word and. So A is there, N is there, T is there. So why can't I give these A, N, T in a different networks? So one network for A, another input network for N, another input network for T. Second time I can build 5. Okay. So can I use the simple ANN repeatedly for series of input? You can, but the challenge here is series means it is not many, it is series of input. See this diagram, it will be clear. So I am giving one input here, I am getting one output out of that. So I am giving second input, I am getting second output. I am giving third input, I am getting an output related to the third input. So these are all like many inputs. I am giving the input in different neural networks, but this is not a series. Series means what will happen? I am giving one input, I am getting one output. So that output will have some influence on the second input. So I'm getting some second output. So second output will have some influence on the third input to decide what should be the third output. So every output will be decided not only based on the current input, it is based on the previous inputs also. That is called series of inputs. Inputs are connected together sequentially. So it is having some sort of impact or influence on its neighbors. So simply with ANN or vanilla network, we cannot solve the problem. So we are going towards recurrent neural network, RNN. So what the RNN is doing means it is remembering the past. It is not remembering only the current input what you are giving, it is remembering the past also. So its decision is influenced by what it has learned from the past. So if it is fifth output, it depends on fourth output, third output, second output, first output. Okay, so RNN remembers the things learned from the prior inputs while generating the output. And the output is not just influenced by weight, but the context based on the prior input. You see the scenario in the last one. Same input could produce different output depending on previous input in the series. In the artificial neural network, what will happen? If I give a set of input, some output is coming, right? So if I give same set of input, same output will come for me, how much ever time I have. But here what is happening means I can give the same input, but I will get different output depending on the previous input because it is serially connected, right? So it will be very clear with this example you see. H, this is the first letter I am giving. So this is input layer, hidden, we have input layer, hidden layer and output layer. If I input the character H, the system is predicting it as E. So this is the first output I'm getting. So next I am giving predict what could be the next output. So this L is not based on only this E, it is based on the previous input also. Influence from the previous one. So L is there. Now I am giving L. So here I am getting L. Then again I am giving L. Here I am getting O. So each time when I give an input character, it is taking that input also as well as the previous output also in consideration to bring out what should be the current Sorry for the interruption. Network problem. Okay.
Okay.
Now, if
Now,
you see
if
here,
you see here,
it is getting echo. Okay, so the third input, what I am giving.
சரி
Yes, it's proper now. So the third input which I am giving is the letter L. And the fourth input, what I am giving is the letter L. But when I give for the third time, the output is L. But when I give the same character, same input for the fourth time, output is O. Okay. So same input can produce different output depending on previous input in the series. So current output is not dependent only on the current input, it depends on the previous input also. So how it is being done means, so this is a normal neural network. So each layer will be having its own set of weights and biases. Okay. So here one input layer is there, one output layer is there, and 3 hidden layers are there. Okay. So in the first hidden layer, weight 1, bias 1, weight 2, bias 2, and weight 3, bias 3. So each layer is having its own set of weight and bias. That means these are all these weights and biases are different. So different means each layer is independent. It is working independently. They don't memorize the prior output. But here, when you come to RNN, all the hidden layers will be having same weight and same bias. That means all these are having dependent activations. So everything is dependent on the previous thing. So same weight and bias will be there for all the layers. That's the beauty of RNN. So here you can make out. To start with, we are having H0, that is hidden. So here you are having input X1. So weight for the inputs are termed as WX, WX, WX. And weight for all the hidden layers are WH, WH, WH. There is no change in weight in any of the layer. So output layer weights means WY. So it will be same for irrespective of the output. And here, irrespective of the input, we will be having same weights and bias. Now input is given. The previous diagram is unfolded here. That's it. So the input is given, and here is you are having hidden neuron, and you are getting an output. So second input is given, and the information from previous hidden layer also is coming. Current input also is coming to decide what is the output. So like that, it keeps going, and that's how RNN works. So it's just simple mathematical thing to refer how to calculate the current state and all. So current state, the current hidden is like a function on the previous one. This is the previous hidden state, and the current input is we have seen. And we know that some sort of activation function so some sort of activation function need to be applied to have a nonlinear activity, right? So some functions are there like sigmoid, softmax, and tan H. So those kind of activation functions are available. So now the current hidden layer, apply the tan H hidden layer. when you apply the damage function, it is getting, oh, now it is proper. Getting, oh, now it is proper. So it depends on the weight at recurrent neuron and weight at, this is input neuron. So wherever X is there, it is input neuron, and this is previous recurrent neuron. Right? So to calculate the output, what we need, voice is getting echoed. I have connected with only one speaker. No problem from my side. This is
தமிழ்நாட்டு வீதியில போய் சாதி கட்டமைப்பு அப்படியே இருக்கணும்னு சொன்னீங்கன்னா யாரும் ஏத்துக்க மாட்டாங்க. கோல்வால்கர் சொன்னாரு பஞ்ச் ஆஃப் பேட்ஸ்னு.
Participants, kindly mute yourself. Vail Sakti, please mute yourself.
okay. So in RNN, it is passing the previous hidden state to next step of sequence. So the input and previous hidden state are combined together to form the vector. So you can make, take this up. So here comes your input. So this is your input, and here you are having previous hidden. So these two are getting combined to form a vector like this, and then it goes through an activation function. So the activation function here, what we are using is tanh activation function. So tanh activation function means it is squeezing the data between -1 to +1. So that's why we are using the activation function. Mostly in the hidden layers, this type of activation function will be used. So when you are working on the output layer, you can use either sigmoid function, or else you can use softmax function also. So in the sense, sigmoid function, it is useful for your binary classification. So it squeezes the value like 0 to 1, and here you are having 0.5. So it will be like this. So below 0.5 and all, it will be taken as one class, and above 0.5 will be taken as another class. So this sigmoid function will be useful when you are going for binary class classification. And you have another activation function called the softmax. So this will also be giving the value between 0 to 1 only, but it will be apple, orange, gray. So I am giving input now. So it will be predicted like, in case if that is an apple, so it may be predicted like 70% as apple, and 2% as orange, and 1% may be gray. So all together, put together, you will get 1 because it is specifying the probability. So this kind of multi-class problem can be solved using softmax activation function. So we should know where we are using that activation function. Based on that, we can decide what type of activation function is needed. So in hidden layers and all, we can use tan H activation function. So the output from here will be a new, after applying this tan H activation function, output will be your new hidden state, fine. So this is how the initial state is getting work. So as I told, tan H function, it is speeching the value between -1 to +1, and it is help regulating the values flowing through the network. You can see when it is 5 and 0.5, -0.5, and how the value was transformed here, see 0.99 and -0.46. So whatever may be the range of values you are giving as input, everything will be speeched between -1 to +1, so that some sort of regulation of data will be there to handle out. There won't be any much deviation or difference between those values, right? So now this is just an example. With tan H or without tan H, if you are not using that activation function, what will happen? If you use the activation function, what is happening? So what was our input? First input was 5 and last input was -0.5. So without a tan H function, without the activation function, finally how it is coming? See, 405 and -40.5. Can you make out within that 4 hidden units? So much of drastic changes are happening in the input. But if you see in with tan H, so it is giving 0.99, and you can make out from each hidden layer point of view, there is no much difference between the values. So you see, it is passing through each hidden layers, right? So that time you can make out there won't be much difference between those data which we are taking. So it is regulating the data flow. It is helping to regulate the data flow through the network. Okay. So now how and all that is how the RNN works, and where I can use this RNN means without RNN, pure conventional mode of neural network means if you have a fixed size of input, you can go for that, like image classification, no issue. Now, for the image, describe the image in sequence of words. And another scenario is a sequence input. So it is useful in sentiment analysis. So this one, like so sequence input and single output. In that scenario also RNN will help you. Sequence input, sequence output. It is used in machine translation. Like one sentence is given in English, so you are having series of input. The sentence is translated into some other language. So in that language also you will be getting some series of outputs. So sequence of input, sequence of output, and sometimes synced sequence input output. It will be used in video classification. So when you when you are working on video related projects, your video cannot be give as a input directly to the system just like that, right? So videos will be segregated into frames, and you have to identify the key frame. And within a period of time, you have to check out what should be the sequence of the frames to be kept for analysis. Okay, so all these scenarios can be used for RNN. So this just what we have seen now. So it is sentiment classification. So many inputs are given, series of words are there, and it is predicting one output, positive sentiment or negative sentiment. Image captioning, you give one image and you will get a caption for the image, description for the image. It is not only for image, You can apply the same thing for the video also. You play a video and you give a description for the video. And also you can make your system to write a story for you also. Like a series of images can be given, first image, second image, third image, like that. You can give some set of series of n inputs, n images to the system. And based on the connectivity between those images, a system can build up a story for you. That's also possible. And here it is language translation. So first paragraph is in English and it is translated into another language called French. So like this, some varieties of based on how the sequence, based on the type of input what we are giving. Fine. Now RNN is having these many applications. So why should we go for RNN works fine if you have dependence. If I give H, it is giving E. If I give E, it will give L. If I give L, it will. But it fails to understand the context behind the input when it is a very large document. Something like prediction is asked, like I can speak fluently dash. Then by looking at this, the system will try to fill this as English. But the 20 years in space. So the 4-5 paragraphs above. So it is not remember. So I hope so. Hereafter there won't be a problem. I have connected my hotspot. So that's the problem. We are moving towards RNN because of this, LSTM because of this short-term dependency. Okay. And one more problem, what RNN was, why that the problem is happening for RNN. It is like short-term memory dependency means the problem is vanishing gradient problem. So vanishing gradient problem means whenever you are calculating your new weight for the hidden layer, the weight is calculated like new weight equal to old weight minus learning rate into gradient. So the learning rate, of course, it will be like one fixed constant value, and the gradient will keep on changing. So if the gradient value becomes extremely small, it will not contribute too much into the learning part. You can make out here the gradient is keep on diminishing, and the updated value here is 0.001. So the old weight was 2.1, and when you subtract this new gradient value, you will get 2.0999. That is not much of difference. That is vanishing gradient problem, and that's the main problem behind this short-term memory dependency of RNN. That's why we are moving towards LSTM, that is long short-term memory. Here, it's a use case. From this, you can understand why this LSTM is needed. Actually, this is a customer review that has been given for a breakfast cereal. So the review has given like this. Amazing. This box of cereal gave me a perfectly balanced breakfast as all things should be. I only ate half of it, but will definitely be buying again. Now, if this is the case, if you use RNN, what will happen means it won't remember the past things, right? So whatever the current thing, it is not on, this review is not purely giving positive review, not purely giving negative review. So it is mixed. So amazing, it is positive. This box of cereal gave me a perfectly balanced breakfast, perfectly balanced. So it is a positive review. I only ate half of it. This is a negative review, but will definitely be buying again. So this is a positive review. So it is like having mixed of both positive and negative. So because of that short-term dependency, the output may not be proper. But when you use LSTM, the system will know which are all the words to be kept in memory and which are all the words to be forgotten from the memory. So you can make out here, some words are standing out in a black, bold characters, and some are grayed out. So those grayed out words are not useful for me in predicting the review of this product. So I can take only the bold letters like amazing, perfectly balanced breakfast, will definitely be buying again, and I am giving the review as positive. Okay. So the LSTM knows which things to keep in memory, which things to forget from memory. So that is the beauty of LSTM. So let us see how it works just for a few things. Then we can go ahead with a few demo cases. So the architecture goes like this. You have input layer, you have output layer. Like RNN, we will be having connection with the previous hidden layers also. But the difference between the RNN and LSTM is recurrent connections are hidden layer nodes. So previously it was like a hidden layer 1 to hidden layer 2, hidden layer 2 to hidden layer 3. The connection went on like that. But here, the connection is introduced in such a way that output of the hidden layer is acting as an input for the same hidden layer also to reiterate and to check out which needs to be kept and which needs to be forgot. Okay, so the connection is reiterating within the hidden layer also. So you can make out here the architecture. So first at the 0th timestamp, you are giving the input, you are having two hidden layers, and that is giving some output. And now at the first timestamp, input is also going, and this is hidden layer 1 and this is hidden layer 2, right? So you are getting where and all you are getting input, you see. You check this one, you are getting the input also, and you are getting the input from previous hidden layer also, and you are getting input from the same hidden layer in previous timestamp also. From here you are getting, so the system will understand from the previous hidden layer also. It is not only the previous hidden layer from the current timestamp, it is from the previous timestamp also. It is predicting what should be the output. You see the last, this one, it will have the influence of all these inputs and this previous hidden layer and same hidden layer from previous timestamp. Understand the difference. Previous hidden layer means hidden layer 1. So this is how LSTM works. Okay, now what component in the LSTM makes the STM works like that. Okay, so having these components, you have 3 gates like in gate, forget, and output gate, and sense state it over time. Each one to okay. So first, this is the control.
Excuse me, Dr. Kavita ma'am. Hello, excuse me.
The overall structure will be like this. All the gates, cell, everything are included here. Let us see one by one. Just for the notation purpose, this red color represents the activation function sigmoid, and the blue color represents the activation function tan H, and this into mark represent point-wise multiplication. Like vector, 2 vectors are there means element-wise multiplication will be done. And similarly point-wise addition, and finally the concatenation, and keeps going to the next cell or next state. So the core components on this LSTM are cell state and various gates. So these two are very important, cell state and gates. Gates means input gate, output gate, and all that, right? So cell state can carry the relevant information throughout the processing, and as the cell state keeps on going, information gets added or information may get removed. Okay, and the gates are deciding which information to be allowed to the cell, whether to keep or forget during the training. So a few GIF illustrations are there so that you can get a proper idea. So already we have seen, right, sigmoid activation. The range is from 0 to 1. So it is helpful to update or forget our data. Sigmoid is mostly used for binary classification. So it will be like take 0.5 as a threshold, and less than 0.5 as one class and greater than 0.5 as another class. Here what will happen means
general economics, non-natural economics, agricultural economics, திருப்பி ஒரு ஜெனரலா இது நான் காப்பி பண்ணிட்டேனோ நீ பண்ணிக்கிறியா?
So less than 0.5 you can keep it like forget the data. Greater than 0.5 you can keep it like include the data, keep the data in your memory. So update the data in your memory, right? So that is how
பார்க்கணுமா? கையில ஸ்பிளிட் அப் சொல்லுங்க கிளாஸோடது. உங்க கிளாஸ் ரெஜிஸ்டர் நம்பர் ஸ்பிளிட் அப் சொல்லு. 84 இருந்து
so we are making use of
அனுப்பவே இல்லடா அவங்க ஸ்பிளிட் அப் கொடுத்தது. நம்ம கொடுத்தோம்லடா அவங்க எக்ஸாம் செக்ஷனுக்கு ஞாபகம் இருக்கா? போட்டோ இருக்கா உன்கிட்ட?
Harsanya madam, kindly mute yourself. Harsanya madam.
Yes, thank you. We are making use of this concept to help the system to forget or keep the data. That's why we are using this activation function. So let us see this three gates, how it is working. Forget here. The information from input, you can make out information from previous, this is hidden state, previous hidden state, and information is from current input. So these two are combined together and the activation function used here is sigmoid activation. So that is between 0 and 1. Closer to 0 means forget, closer to 1 means keep. So this is the purpose of forget gate. So it is deciding which one to keep and which one to forget. And the next one, if you see, it is input gate. So how the input gate will perform is to update, its purpose is to update the cell state. So it passes the previous hidden state and current input to the sigmoid function. Because this sigmoid function decides whether the information what you are getting now is important or not. Previous hidden state and current input. So you can make out. So it is previous hidden state and current input. So again, it is made at a vector and it is given to this sigmoid function to decide whether it is important or not. Same previous hidden state and current input is passed to TANH function also to regulate the flow. Here you can make out the same input is going here also and here also. Okay. So after that, you will get one output from TANH activation function, one output from sigmoid activation function. You can multiply both the things. And finally, the sigmoid output will decide which information is important to keep from the TANH output. So these two are multiplied and final, this output, what you are getting will decide which one to keep and which one to forget. So this is input gate. And last one is output gate. So before going to that, we should know about the cell state also. Cell state, how to decide or how the current cell state is being calculated with previous cell state point to multiplied by the forget vector. After getting the input, here we are getting the input, right? After getting the input, you know which one to be keep, which one to forget. And we are utilizing the previous cell information also. There is a possibility of dropping the values in cell state. If it gets multiplied by the values near 0, that means forget. So take the output from input gate and do the point-wise addition which updates the cell state, use cell state. So from this is input gate, right? So from this input part, you are getting the output, and from previous cell state, you are getting the information, and finally that is passed as the new cell state. So this is previous cell and this is new cell state, right? The last one is output gate. How to decide what should be the next hidden state should be. So first pass the previous hidden state and current input to the sigmoid function. So previous hidden state and current input. So what the current input is here, right? So the current input is coming here and the previous hidden is coming. So both two are applied to the sigmoid function and newly modified cell state to the tan H function. So this from a cell you are getting, right? So that will be given to tan H. Then this input and this input will go for point-wise multiplication. And finally, this output will give you, output gate will give you what should be the next cell state and what should be the next output. That is input for the next unit. Okay. So this is how the LSTM works. Like it is based on two main components are there. One is gate, another one cell. So gates, three gates are there. One is input gate and another one forget gate and another one output gate. So let me summarize about the gate. So forget gate decides what is relevant to keep for the prior steps. For the upcoming steps, which one need to keep, okay, and which one need to forget. And input gate decides what info is relevant to add from the current step. Currently, I am supplying some input, right? So using this forget gate as well as the current input, what is the information relevant currently? That is the purpose of input gate. Then output gate determines what should be the next hidden state should be. So the output gate depends on both this forget gate as well as input gate. This is just like a summarization of gate. And that's how the LSTM works. Some use cases, if we need to check upon, wherever series of input is needed, you can go for this kind of RNN or LSTM. It is helpful in solving the time series problem. Now in the demo, we can see, we can take this particular domain and we can look into how it can be solved. Time series. It is like how variables keep on changing over time. So it could be like used for weather prediction, or it could be used for climate prediction. Both are different actually. Weather means it represents the current situation. Climate means it represents like some patterns of weather that has happened for maybe a month over time or years together. What is happening? That is climate data. So it is like a prehistorical data, and weather is like a short-term data, focusing only on the current weather. Then you can use it for healthcare related to ECG, EEG signals, or it can be used in the finance segment, like stock market, sales and demand forecasting, traffic management, traffic prediction. So all these things can be get out using the time series prediction. Then we have NLP. So prediction of the next word in the sentence, you can generate the text, or you can go for autocomplete. When you type automatically, the other sentence is getting completed, right? So you can go for autocomplete, machine translation, sentiment analysis, opinion meaning. Many applications are there. Then you have speech recognition. Speech to text or text to speech can be recognized, and then video analysis, because it is going to have some series of image frames, and so that you can understand what is there in the video, and you can have action recognition, the gesture recognition, motion recognition, those things and all can be recognized, because gesture means it is sequentially they are performing something and we can get to know what they are trying to say, right? So the major application here is sign language detection for those who are in path, and path prediction in robotics, and we can have dialogue system. Like this, in so many places, this kind of RNN or LSTM will be used. So in particular, we'll take one domain here now, time series, and we can look for the demo. Okay. So before going into the demo, I would like to tell the challenge with respect to one particular use case, that is NLP. So how difficult for the system to do all these things. You see, sometimes contextual words or phrases, homonyms might be there. Like, see the sentence, I ran to the store because we ran out of milk. Same word is used here. Here also ran, here also ran. But the meaning of ran is different in both the places. I ran to the store means I am literally running to the store using my legs. We ran out of milk. That means shortage of milk. There is no milk in my home, so I am running to the store. So these kind of homonyms will make a problem. So we have to train the system in such a way that the context behind the word will be understandable by the system. Then sometimes we may be using sarcastic word. We may not telling something directly. The locker room smells really good. Awesome. Awesome means it is like a positive, right? But here it is not like awesome. Awesome is not having direct meaning. Locker room means always it will be kept closed and there will be having some rotten smell or pungent smell. It is not good actually. But I am telling it in a sarcastic way. Okay. How the system will find out whether I am telling with a direct meaning or sarcastic meaning. And also you see ambiguity. Look at this second one. Lecture time is morning 9 o'clock. Students are reaching the class at 9:20. Teacher is asking, what is the time? This we all would have faced, right? Teacher will be quite natural. It is quite natural. Teacher will be asking, what is the time now? What is the intention of the teacher? Intention of the teacher is not to know what is the current time, that is 9:20. He or she wants to stress out that time is, the actual time is, lecturing time is 9, but the students have reached the class late. Okay. So in this place, we should not take the direct meaning and the system should not give the answer for this question. Fine. Sometimes with this WhatsApp, SMS, everything, so many slang languages and colloquialization have happened. So like this, whenever you implement any system, so many challenges will be there. So we should know what domain, where you are applying. Based on that, the challenges, issues will keep on changing. Right? Now we can move ahead to the demo. So this demo is built upon using KERAS and TensorFlow. So KERAS is a Python-based library, and we have TensorFlow also. Whenever you come to the world of neural network or deep learning, these two names, that is KERAS and TensorFlow, they are consistently rise to the top. While they are often mentioned together whenever you implement program, there are some critical differentiation also. KERAS is not an independent deep learning framework, but rather it is a high-level neural network. KERAS is a high-level neural network API that is running on the top of other frameworks, with like TensorFlow being most popular backend. Like TensorFlow is here, KERAS is a high-level API that is built on top of this TensorFlow. So TensorFlow is providing an underlying framework with unparalleled flexibility and scalability. KERAS, on the hand, offers a friendly interface for quick experimentation by keeping this TensorFlow as a base. Fine. So now we can move on to the demo part. So here it is like time series prediction, and we are trying to use the RNN. So let me show how the data set looks like, then we can go ahead. This monthly CSV. So if you see the data set here, it is actually in a CSV form, monthly sunspots CSV. like in the sun, some spots will get generated based on the magnetic radiation that is there. Okay, so number of spots that is generated, it keeps on varying. So the astronauts try to analyze those parts, how it is keep on varying. Okay, so now that is the value is captured for every month. So this is actually, if you see, in 1749 January month, 1749 February, March, April. So how many sunspots were there? Like that in 1749, all 12 months. Then 1750, 12 months. Okay, so like that it keep on they are going for prediction. Now, yes, let me show. So I hope so the Jupyter notebook is visible. And here we are importing some libraries, basic libraries like NumPy, Pandas, and we import KERAS, some packages like for building the RNN like sequential dense. So first time when you use the KERAS or TensorFlow, it might not be there in your system. So it will show you the error message like no module named KERAS found or no module named TensorFlow found. So there are two ways to incorporate into your environment. So you can make out here. Either you can use the pip statement, pip install, and you give the TensorFlow or KERAS, it will get installed. Or else another way is you go to the Anaconda navigator, and here environment, left side if you see home, environment and all will be there. Click on the environment, and in the right side window you will be having all the installed packages. There you can check out, here search box is there on the right side. You can check out whether KERAS is there or not. If I start typing, it will come. So I have installed KERAS in my environment, so it is coming here. If the KERAS is not installed in yours, in this is first, if we assume like a column, in this third one, here it is there, right? It will show you options like installed, not installed, and updatable. So click on the not installed. All the Python packages, frameworks, library available, which are not installed in your system will get displayed. So you can choose KERAS and you can click on that, and down you can see the button apply. Once you press apply, automatically it will get installed. So these are all the two ways how you can install. Either you can use the pip command in your program and you can install, or you can go to the Anaconda navigator and get it installed. So from KERAS, different packages are getting installed here. Sequential, because we are going to keep on adding the layers sequentially, right? So first we will have input layer, then we will have hidden layer, 1, 2, 3, like RNN layers will be there. And finally, to get the output, I will be having some dense layer, like feed forward network will be there. So I'm going to add those layers sequentially. So sequential is added. And my layers are RNN layers and dense layer. Dense layer means it is like feed forward network, that final network which is deciding the output. And I need to do some pre-processing on the data set, right? So my data set may be having, if you see this Excel sheet, one is having 58 value, another one is having 158.6 value. So there is a lot of differences between them. So I need to standardize those values either between -1 to +1 or 0 to 1. Okay. And how do I evaluate my system? I have developed a model. How do I evaluate the system? I can evaluate using, like, since this is like a regression problem, it is based on the numbers, continuous output is continuous numbers, right? Here the number of sunspots, so it is continuous numbers. So I'm using mean squared error. So all these are pre-built packages, pre-built functions available in this KERAS package or FKLearn package. Directly we can use it. So the data set which I have shown here is downloaded from this URL also. URL, you can download it from here, or else after this session, the data set as well as this program, I will share it to Vijaya ma'am. In turn, she will be sharing it to you. So now the CSV, we can read it in the data frame. And here it is, the monthly sunspots.csv. So our focus is, we don't want this month, we want this series, right? Serially it is coming, so series. So I want only this data, sunspots data. So I'm taking only the second column. So in Python, as the index starts from 1, here it means 1 means it is a second column. So this colon represent all the rows, So first parameter is the rows and second parameter is column. So colon represent all the rows. I'm going to take all the values from which column? From the second column. So it is taken. So here you are getting. So I don't bother about this month detail. I need to bother about only the sunspot. So the sunspot is directly got. So it is stored in a variable data. So now I am finding out the size of the data. It is totally I am having 2,820 records in it. So now this, since I have directly taken this from the data frame. So CSV file that is loaded into the data frame format. Since I am taking from that, the data will be in a pandas series format. So to do some operations, I need to convert that into a NumPy array. So I am converting that using this to NumPy format. And I am reshaping it so that it will be acting like a one-dimensional array for me. So reshape function is for reshaping any sort of data to my customized form. So first one parameter represent number of rows and second parameter represent number of columns. So you might be wondering that why I gave -1. -1 means I am not bothering about rows. I can have 5 rows, I can have 500 rows, I can have 5 lakh rows, whatever it is. Based on the data set, you keep as many rows you want. I am bothering only about this. I need it as a one column format. Okay, one dimensional array, one column. It is like a column array. So many rows will be there, but only one column will be there. So I'm reshaping that. So as I said, because of deviations in the values, we have to standardize the value. So we can use the min-max scalar for standardization by giving the minimum value as 0 and the maximum value as 1. So now originally whatever the value the data is having, everything will be squished between 0 and 1. Okay. So now here in this line, the scalar is defined, but that has to be applied to your data set, right? So use the scalar object. Here I have fixed the scalar object. Why we are fixing the scalar object means, now for this example, for this program, I am using 0, 1. For some other program, I may use -1 to +1. So that time the object will be different, right? So first I am fixing the object, generating the object, using the object upon this data, and I am transforming my original data to scaled data. So use that object, scalar, fit to transform which data to be transformed? The variable that is data is stored in the variable data. So transform the data and use this object. So now finally you are having the data in your hand in whichever way it is suitable for analysis. Next, we have to make the training set separately and test set separately, right? So how much percentage for training, how much percentage of testing? So since you would have gone through the ML courses, you might be knowing about the training testing process and all. So I'm not touching that here. Here we are using it like 70% for training and 30% for testing purpose. So I'm giving the split ratio here. It is like 70%. If you have used some labeled data directly, you would have used the train test split function and you would have come across. But now here we are having it in the form of one-dimensional array, and also it is a time series data. So first 70% of data is taken for training, and the rest of the 30% is taken for testing. Otherwise, in a normal ML model, randomly it will assign the data, right? But here it is like first 70 for time. So that is done here. Training data range of split. So 70% of data will come here. The rest of the data will go for test data. So you can make out the size of the training data and test data also here. It is 1973 for training and 847 for testing. Okay. Now the training data, test data is fine. But now I want the system to be ready for my analysis base that suits for the time series, right? So directly I cannot give the data like that. So how I can make the data to suit for the analysis means, let me give you a small example so that you can understand. So consider that you are having the data like this: 0, 10, 20, 30, 40, 50, 60, 70. Let us stop here. Okay. And consider, assume that you are having the time step as 3. That means based on this 2 data, I am going to predict the third data. So the every third data will be predicted based on the previous 2 data. For example, for this data set, you see here timestamp first. You are taking 0th data and first data. That means 0, 10. Time step 2. So based on this 0 and 10, you are predicting 20. And based on 2 and 3. So what is there in the second position? 20. And third position, 30. So fourth position will be predicted based on this 40. Then t equal to 4, 5. So that is 40, 50. And here the time step 6 will get predicted. So this can be discarded. Okay. So for example, if you take the time step value as 3, every third value is predicted based on the previous 2 values, 0 and 1 predicting 2, 2, 3 predicting 4, 4, 5 and predicting 6. This is how the time step value goes in our time series prediction. Okay. So the input is previous time step value. So to get the output of this, input is previous time step value. Time step value is this one, right? Now, as per this sunspots data, how the data is serially given, see, every month they are recording. That means from January to December, they are recording the number of sunspots. So it is like a monthly wise data. For 1 year, 12 recorded values are there. So in this example, we are going to take the time steps value as 12. So hope you get to know what is the thing behind on fixing the time steps value. Since we are recording it for every month, the time steps value is given as 12. Now we have to prepare the one-dimensional array data to like this, right? So like this, I have to prepare. So actually, this is my X value and this is my Y value. So this is my input and this is our output. So we are predicting this based on this value. So I have to transform the one-dimensional data. Here, this 1D data is there, right? So like this only we are also having now. So this data has to be transformed into this form. So how it is done, see. So here a Python function is returned like get xy, so that we can pass the training data separately and test data separately and get it done. So the parameters are the data is sent and time steps. So how much is the time step? 12 is sent. So here what we are doing is, so first we are making up the y. So hope you remember now what is y. So this is y. So time step equal to 3 means what we are trying to do, every third value. So this is third value. And after that, this is third value. And this is third value. Every third value is separately taken, right? So here, now we have to take, since the time step value is 12, we have to take every 12th value as a separate one. Okay. So here, the time step is 12. So in Y position, every 12th value has to be taken. So that we are taking, first we have to find out which places, then we can take the data. So how to fix out which places means, we are using the arrange function in the NumPy array. It is having 3 parameters. The first parameter is start, second parameter is stop, and third parameter is step. When to start, so when to start, when to stop, and what is the time step, how you have to step each time. So totally now here you would have seen 1973 training data are available, right? So 1973. So that is equally actually 1968 plus 5. The remaining 5 data can be discarded. So this 1968 timestamp is 12, right? So that is actually 12 into 164. So you have to make 164 different entries. That means, so first you will take from 12th place, next you will take from 24th place, next you will take from 36th place, next you will take from 48th place. Like that you keep on taking till you reach the end. So this is 1, this is 2, this is 3rd. Like that, if you see, you will get 164, right? So this is Y. We are taking Y here. Now, then we have to prepare X also, right? So X we are getting here like this. So rows X means how many rows are there? How many rows here? 164 rows are there. That 164 rows, how you are getting length of Y. So here we are getting the length of Y as 164, right? So that 164 into time steps. Time steps is 12. So totally you will get that 1968 data. Okay. So that is reshaped into the form how we want it, like this. It has to be reshaped. Like X will be like this. So for first year, so 12 values will be there. For the second year, 12 values will be there. So like this, you will have 164 entries. Okay. So what is the meaning actually? Here, some 12 values are there, right? So based on this, you are going to predict this value. Based on this second set of value, you are going to predict this value. So in this way, the data is arranged here. After arranging that, we have to build the model. Now here we are building the model using a function, user-defined function, that is create RNN. So in create RNN, we are passing the number of hidden units, number of dense units, what is the input shape, and what activation function we need. Everything has to be passed here. And as I said earlier, all these layers, input layer, then RNN layers, then dense layer to get the output, and that is final output layer. Everything to be added sequentially, one by one in our model. So model equal to sequential model data. First, I'm adding the simple RNN layer. So hidden units, it is coming from the first parameter. It depends on the number of hidden units. Here I have fixed it like 3. It depends on the data size, data variability, and the pattern which you are having in the data set, and the number of training cases, complexity of the data, how many outliers are present. So it depends on many things. You can vary this hidden unit accordingly, and you can check out for which number of hidden units your model is giving good result. Okay. So just for experimentation purpose, 3 are given. So hidden unit equal to 3, and input shape equal to this one, input shape. So we are giving it in the form of every year wise, right? The time step is 12. So 12, 1. So it is like a single dimensional column array with 12 entries, 12. So that is the input shape. And the last parameter is activation. So activation, here you have hidden layer, RNN layer, and finally you are having output layer. So for both, we are going to use tanh function because it is involved with, it is not like binary classification or multi-class classification. Otherwise, we would have used, instead of tanh, we would have used sigmoid or softmax. Since it is numeric based, here we are using tanh. Okay. So in building the simple RMN, hidden units are given, input shape is given, and activation equal to tanh. Then after that, we are adding the dense layer. That is the layer which is going to decide your output. Feed forward normal neural network. So units equal to dense unit. How many units you want to have it like the output? So I want upon this every time I want one single output, right? One number is needed as an output. So I'm giving the dense unit as number of dense unit as 1. And activation is tanh because it is a continuous number. And of course, finally, we have to evaluate the model. So we are using the last function as mean squared error. And the optimization is add-on optimization. Everything is created here and the model is getting returned. So once we execute this statement, the model is created and it is giving you an empty model. Now we have to fit that model for our data set. So model.fitoff, we are taking the same object here. Model.fitoff, train X, train Y. So this is for training purpose, we are giving the X and we are giving the Y. So this is for input purpose and this is your output. So how we are giving here. Okay. So this is input and here you are having output. And epochs. Epochs, we can set the epoch by experimentally, we can fix it out also. So epoch is nothing but like single pass of entire training data set through the learning algorithm. Suppose if here I have given it like 20, that means training set will pass through the algorithm 20 times. Okay. And batch size is the number of training examples that you are feeding in one particular pass. The model is fit once you run. So how many epochs are there? 20 epochs. So it is running. So first epoch, second epoch out of 20, it is running. So every time you can make out the initial loss was 0.08, then it keeps diminishing and finally we are getting 0.0042. This is for training purpose. Fine. So now the training is done. We have to predict for the test data set. So you can predict for the like training data set also. Why we are predicting it for the training data set means finally we can draw a plot and we can check out actual data how it is and how our model is predicting. Is there any deviation or not, can be checked. Okay. For both the train data set and test data set, the model is predicted. After predicting, here this is just a function to print the error values. Root mean square error is preferred here. So there are different types of error values are there when you come to the numeric function. So actually, what is an error means? The deviation between actual and predicted value. That is error. So directly you can take error. But what will happen is, in case, consider that here you are having actual and here you are having predicted. Actual is 10, predictor also 10. You are building a model and your model is predicting it as 10. And sometimes here actual is 5 and your model is predicting it as 10. Actual is 15, your model is predicting it as 10. If this is the case. So now what is the error? Simply directly if you take error, what will happen? 10 minus 10, 0. 5 minus 10, minus 5. 15 minus 10, 5. So overall error, summation, overall error, if you take, what will happen? It will become 0. So that is the problem with error. So people started going for absolute error. So absolute error means without sign. So without sign, what will happen now? Here it will become 0, this will become 5, and this will become 5, and here it will be 10. Fine. So this will be the case. In case, suppose we have one more entry, like 70, and again it is predicted as 15, then the deviation is 2. Okay, so it will come like this. We started going for squared error to make it like, if the difference is more, it has penalization should be more. Here the difference is 2. Here the difference is 5. So more penalization or punishment should be given to these records than this record. Okay. So in that case, if you see, this will become 25, this will become 25, and this will become 4. The difference you can make out here. Here the difference is only 3. But here can you make out the differences like nearly 21. So the smaller the error, smaller the value will be. Bigger the error, bigger punishment will be here. Bigger error will be there. That's why we are moving towards squared error. So we are finding here root mean squared for the training as well as testing. And you can make out here for training it is 0.064 and for test it is 0.081. Both are less than 0.1. So it is a good model. And finally, we are going to plot the result based on the training. Train y, test y are the actual y. Train predict, test predict are the predicted values of our model. Okay. So actual and all we have appended separately, and predicted and all we have made it separately, because you know how we have framed this train and the test, right? So train first 70% of data was for train and next 30%. So we have appended here, and we are trying to plot those things. So here you can make out a different function, AXP line. It is just to draw a straight line to differentiate below that line, sorry, before that line it is training data set, and after that line it is test data set. Here you can make out. So let me zoom it out. So here you can make out this line is there, right? So this red line is the demarcation between the train and test data, and blue color line represent the actual data, and this orange line represent the predicted data. More or less it is same, right? So this is how a time series prediction is happening in our using our RNN. So the same thing, let me try it with a different data set using LSTM, and other applications and all will be posted. Right now LSTM. So again here we are importing some libraries which are needed for that, and the TensorFlow is having some predefined data sets also. You can take it from tensorflow.keras.datasets. And we are taking here IMDb dataset. It is actually a movie review dataset, and it is having, I think, maybe 25,000 reviews are there. So movie reviews are there. And similarly, the model sequential, LSTM, 10, somebody, everything are taken here. Fine. So the maximum number of features, you can fix it like that, maximum length, because it is based on the text data, right? So how many words or how many in review, in a single review, how many words might be there, how many characters they might be using. So these things and all, you can fix it out. Maximum length is kept as 500. So apart from that, if anything is there, that will not be considered for our analysis. So let's select that, we can fix it. Now we have to take like train data and test data separately. So IMDb.load data. So automatically the data will get loaded as a train data separately and test data separately. And why these pad sequences are needed means to match up. Some reviews may be having only with 10 words, or if you take in terms of characters, it might be with like 175 characters. Some reviews may be with 283 characters. So to match up like a proper standardized matrix form, we need to pad the sequences, remaining elements. Okay, so the maximum length is 500. So we are padding whichever is empty, we are padding that sequences up to the maximum length. So now the data is ready for your analysis. Now you can build the LSTM model. As usual, we are making like sequentially, we are adding the layers one by one. So first we are using the sequential function. Next you are adding the adding the layer, embedding. It is just like converting the positive integer input into a dense vector of fixed size. It is working based on like how the context will work on. Now let me give you a small example for word embedding. Suppose if you have three different objects like cat, man, queen. This is for example purpose, not the same thing is used in this program. And here different contexts are there like living being and another one human and another one gender. So based on the context, some values are assigned for this in this layer. So cat, living being. So the probabilities can be assigned like this. Cat, human, no. So the less probability will be there. Even it may be like 0 also. It is based on how you are training. Man, human, and queen, human, and gender. So whether this word is representing the gender. Man, queen, easily we can figure out the gender. So it is 0.9. Like this, some sort of embedding will be done the first stage. Okay. And next you are adding the LSTM layer. We can fix out the number of units that has to be present in the LSTM. Basically, it depends on the dimension of the output vector which you are putting. And the dense layer, this is the output layer. And finally, you are going to get the output like a positive review or negative review. So I am going to get one output. So one unit is given and activation, sigmoid. So already we have seen the purpose of sigmoid function. It is useful for binary classification. The output will be spaced from 0 to 1 and less than 0.5 as negative review and greater than 0.5 as a positive. Then the model is compiled using the cross entropy loss function and the matrix accuracy. So you can choose the matrix function also. And we are having 10 epochs and batch size 64. That means in a single pass, 64 records have been sent. And every time the training epoch is for 10. So model is fit, and finally you are evaluating the model and you are getting the accuracy as 0.86. That means 86%. This is how the LSTM works. The only thing which we need to know is how we have to proceed with how to give the input. So because it is like pre-built packages, whatever you are giving, it will give the output. So we need to do how to give the input and how to interpret the output which we will be coming. Thank you, everyone. So some other sets of programs are there, like based on the text classification and text prediction, predicting the next word in those sequence. And the data set which we have used also, I will be sharing it to Vijayama so that she can share it to you all. Thank you, everyone.
Thank you so much, ma'am, for sharing such a valuable insight. I'm sure our audience is more inspired and informed after your presentation.
We will now open the floor for the feedback and questionnaire session. If anyone has any questions, feel free to post them in chat box or raise your hand and ask it directly. Let's make this interactive section. Kindly fill the feedback form to everyone.
Thank you, Dr. Kavita ma'am.
Thank you, ma'am.
Could you hear me?
Thank you so much. Yes, ma'am.
Sorry, my phone is not working, so I am coming from another phone.
It's okay.
Participants are requested to fill the feedback. If the participants have any suggestion or feedback or any queries, you can raise. Question இருக்கா?
Vijaya, ma'am.
Yes.
Ma'am, I will be sharing the data set as well as these two programs that is related to time series. Apart from that, with the text classification and text prediction, I will be sharing it. I will send mail to you. You can share it.
Okay, ma'am.
Thank you.
It's great. Thank you, ma'am.
Thank you, ma'am.
And personally, I would like to thank Dr. Kavita from Christ University for having given an elaborate session on RNN and LSTM using KERAS. Her lecture is really wonderful, and I hope for the research scholars it will be very much useful, and for our students, as per the Tansky syllabus, they are having an advanced machine learning lab. In that lab, they have some programs in CNN, RNN, and LSTM. So I hope they also understood how to do that program. Thank you so much, all of you, for your patient and active listening. And once again, all the participants, feedback.
Thank you, ma'am. And I don't know whether they know or not. Dr. Vijaya ma'am is my PhD guide. Whatever the research I am doing now, the seed has been sown by her. So I started learning and doing research by seeing her. Thank you, ma'am.
Though I am your research guide, you have completed PDF. Nowadays, the PhDs who completed PDF are not available. Even I am not yet completed. So she is a scholar crossing the crossing the value of even crossing the limit of Guru. Guruவை மிஞ்சிய சிஷ்யன்னு சொல்லுவாங்கல்ல.
It's not like that, ma'am. That can never happen.
PhD under my guidance. After that, she joined in Mysore University and completed her PDF also. It's a great achievement in her life. Really, she's one of my best scholar. So I appreciate you for your wonderful session. I enjoyed to listen your session, Dr. Kavita, and thank you so much.
Thank you, ma'am.
Thank you all for your active participation. Now, as we near the conclusion of this workshop, I would like to invite S. Ranjini from 2nd MC for vote of thanks.
Happy afternoon, everyone. I'm honored to deliver this vote of thanks for the online state level workshop on recurrent neural network. First, I thank the Lord Almighty for the workshop's success despite challenges. I extend my gratitude to Professor Dr. R. Kavita ma'am for sharing valuable knowledge and expertise. Next, I would like to thank our principal, Dr. S. Vanadi ma'am, for her unwavering support. Then, distinguished participants for their presence and enthusiasm. Next, I would like to thank our head of the department, Dr. A. Rajarajeshwari ma'am, for her guidance and leadership. Then, I would like to thank all conveners, organizing secretaries, and members for their tireless efforts. Now, I extend my special thanks to all head of the departments, professors, and staffs from various colleges for their cooperation. Thank you all. Stand up for the national anthem.
எதுவுமே வச்சுட்டு இல்லைன்னா என்கிட்ட நீங்க கேட்கலாம். டிகிரி சர்டிபிகேட்டும் 2000 கட்டிட்டேன் இல்லையா சார்? ஒரு டாக்குமெண்ட் சர்ச் பண்றதுக்கு 2000 ரூபாய் ஃபீஸ். கொடுக்காமயே போயிடுச்சுன்னா என்ன பண்றதுன்னு பயமா இருக்கு. இல்ல வாரத்துல சனி ஞாயிறு மட்டும் கிளாஸ் வைப்பாங்க. வேலூர் போங்க. கிளாஸ் நல்லா இருக்கும். அருமையா இருக்கும். செம்மையா எடுப்பாங்க. காலையில 10 மணில இருந்து 4 மணி வரைக்கும். அந்த 2 வாரம் 2 நாள் எடுப்பாங்க. சனி ஞாயிறு எடுப்பாங்க. அந்த வாரம் வந்து அசைன்மெண்ட்ஸ் இருக்கும். அந்த மாதிரி 1 மாசம் நடக்கும். இங்க நம்ம கம்ப்யூட்டர் ஸ்கில் இருக்கும்ல, அந்த மாதிரி இருக்கும். டைம் டேபிள் போட்டுட்டு அவங்க
The participants are requested to leave the room. Thank you for your wonderful participation.
19, 20 நம்ம தான் வரணும். 21ஆம் தேதி பிராக்டிக்கல். அடுத்த நாளே எனக்கு உங்க வீட்டுக்கு கண்ணாமன்னு திட்டுவேன். உங்க வீட்டுக்கு தைரியமா பேச மாட்டேங்க. இல்ல 7000 ரூபாய் கட்டணும்னா கூட இன்னைக்கோ இல்ல நாளைக்கோ கொடுத்தா போதும். கேக்குறது 15ஆம் தேதி கேக்குறாங்க. அந்த 15க்குள்ள நான் கட்டின ஃபீஸ் சர்ச் பண்ண முடியாது. 7000 ரூபாய் கட்டினது சர்ச் பண்ண முடியும். என்ன கேக்குது? வெள்ளூர் ஸ்டடி சென்டர் அந்த கான்டாக்ட் நம்பர் நீங்க வச்சிருப்பீங்க. நானே இப்ப அவர்கிட்ட பேசுவோம். நான் பேசுறேன், நீங்க பேசுவீங்கல்ல சார். நீங்க எடுத்த டிடி நம்பர் லிஸ்ட் ஆஃப் கேண்டிடேட்ஸ் எங்களுக்கு அனுப்புங்க. யாரெல்லாம் இந்த நம்பர் உங்களுக்கு ஃபீஸ் பே பண்ணாங்களோ லிஸ்ட் ஆஃப் கேண்டிடேட்ஸ் எங்களுக்கு அனுப்புங்க. அதுல என் பேர் இருக்கும்ல. எங்க வீடு என்னதான் கேக்குறேன். சப்போஸ் நீ கட்டலைன்னா அவங்க எப்படி டிகிரி கொடுத்துருப்பாங்க? பச்சை கலர் கொடுங்கப்பா. யாரோ வராங்க.